Okay, let's continue our discussion of 3.2 polynomial functions. And in this video, we're going to use factoring to find the zeros of polynomial functions. Okay, so if we look at example 2, f of x equals x to the third plus 8x squared minus 4x minus 32. This function is not factored. And so we're going to find all of these different characteristics of this polynomial function. Let's determine the end behavior. For that, we need the leading coefficient, which we're going to call A. I'll use the blue pen. And A is 1, so it's positive. And the degree, the highest exponent, is 3, and that's odd. So if you have a positive leading coefficient and an odd degree, we're going to determine the end behavior as falling on the left and rising on the right. Okay, to find its x-intercepts, we again set the whole equation equal to 0. So 0 equals x to the third plus 8x squared minus 4x minus 32. Because this has 4 terms, let's try factoring this by grouping. So group the first 2 together and the second 2 together. Let's factor out an x squared, giving us x plus 8 inside the parentheses. And then from negative 4x, negative 32, looks like we can factor out another negative 4 with x plus 8 inside the parentheses. So we can factor this as x squared minus 4 and x plus 8. Okay, x squared minus 4 is a difference of perfect squares, so we can factor it again as x minus 2, x plus 2, and then the x plus 8 at the end. So now we can set all of these exponents to 0 to find its x-intercept. So x minus 2 equals 0, x plus 2 equals 0, x plus 8 equals 0. So we have x equals 2, x equals negative 2, and x equals negative 8. Now the multiplicity is up 2 because the exponent of x minus 2 is 1. We say 1, and that's odd. So we know at 2, what's going to happen is it's going to cross at 2. Now x equals negative 2, again, the multiplicity of that factor that came from is 1, so it's odd again. So it's going to cross at negative 2. And then finally at x equals negative 8, the multiplicity is 1 again. So it's odd. And that means at negative 8 crosses. Okay, so the graph crosses, let's see, the x-axis at these x-intercepts at 2, negative 2, and negative 8. And it does not touch and turn around at any of those x-intercepts. So none. To find the y-intercept, we plug in 0 for the x value. So find f of 0. So we just say 0 to the third is 8 times 0 squared minus 4 times 0 minus 32. All of these are 0. So our x-intercept or y-intercept is negative 32. We can determine symmetry after we graph. So we'll go back to it. But with the graph, let's fill it in. So how we can graph this is first put in your arrows for your end behavior. So it goes down and up. And then we can put our x-intercept. So it's at 2, negative 2, and negative 8. Our y-intercept, it's all the way down here. So I didn't give us enough space to put it. So I'm just going to put like all the way down here and say it's going to go down to the way at negative 32. And then let's approach our x-intercept. We know it's going to cross. This is going to be a very rough sketch, so I don't know how high it really goes, but I'm going to have to eventually come back down. Negative 2, it crosses again. And at negative 32, way at the bottom, should be more bottom, but I didn't give you enough space. It goes through that and goes back up. And at 2, it also crosses and it's going to go up. So does this have symmetry? Remember, symmetry, there are 2 types. There's even symmetry or odd symmetry, or y-axis symmetry, or symmetry about the origin. You can see this has no symmetry, so we just say there's no symmetry for this. And then we're done. Okay, so let's take a look at number 3. We have x to the third minus 18x squared plus 81x. Same process, determining the end behavior. The leading coefficient is 1. So this is positive again. The degree is 3. And so we say this is odd. So if you have positive leading coefficient odd, again, it's going to go left, down left, and up on the right. Finding the x-intercepts and its multiplicities, we're going to set the whole thing, the y value equal to 0. So x to the third minus 18x squared plus 81x. And from here, it looks like we can factor out an x first. So factoring x out, we get x squared minus 18x plus 81. And then we have x. We can factor x squared minus 18x plus 81 as x minus, let's see, what multiplies to 81 and adds negative 18 are negative 9, negative 9. So we have x minus 9, x minus 9. Because they're the same repeated factors, we can say that's x minus 9 squared. Okay, so we have our factors, 2 factors. We can set that equal to 0. So we have x equal to 0 and x minus 9 equal to 0, where we get x equals 9. So we have 2 x-intercepts at 0 and 9. So we'll put that in, 0 and 9. And now what are its multiplicities? Well, multiplicity of x equals 0. What's the exponent where it came from? Here we got 1, so it's odd, which means at x equals 0, it's going to cross at x equals 0. At x equals 9, the multiplicity is 2, and that's even. So what's happening at x equals 9? It's going to touch and turn around. Okay, so the graph crosses the x-axis at 0 only, and the graph touches and turns around at x equals 9. Find the y-intercept, that's easy. Just plug in 0 for all the x terms. So we have 0 to the third minus 18, 0 squared plus 81 times 0. So these are all zeros, and so the y-intercept is 0. Determine the symmetry. Let's also just graph it again. And so the arrows tell me that's going to go down on the left-hand side and rise on the right-hand side. So here we're going to approach 0, and it says the graph is going to cross it. So I'm going to cross. You know, I have to eventually come back down to that other x-intercept, and at x equals 9, it's going to touch and turn back up. So you can see there is neither symmetry, no y-axis symmetry, no symmetry about the origin. So we have neither symmetry. Okay, we'll wrap it up here, and then we'll continue in the next video for problems 4 and 5.